Hey everyone, in this video we're looking at using the trapezoidal rule to find or estimate the area of irregular figures. In order to be successful, you're going to apply your trapezoidal rule using the appropriate values and substituting them in where they're required in your formula. And we're also going to look at in class. So in class we'll look more specifically at these things here, constructing an alternative method and then comparing and then stating those appropriate, setting your answer in appropriate units. So this is going to be your in-class success criteria, but in this video we're looking at more specifically for how to use the formula in order to find or estimate the area. So an irregular shape is a shape with no distinct properties, and generally it's like those curved surface shapes that you might have that look kind of like this. And there's no real discerning properties about them that you can get, you can kind of attribute to a formula. So you might see like there might be a parallelogram, another parallelogram, a rhombus, and so forth, and like half a circle. So, but it might be just too curvy, and there's not enough of those distinct shapes that you can discern from formulas. Anyway. An estimate is to like roughly calculate based on given information. So we'll talk about more about that when we do the formulas. So finding the area of a regular shape using the trapezoidal rule. A trapezium or a trapezoidal shape is a shape that has, so a trapezoid is a shape that looks kind of like this. It also, you've got two parallel sides. This length is always going to be different to this length, and two slope sides. So in this shape, when we find the area of it, we actually take A plus B, find the average of those, and then times it by the height, which is like perpendicular to A and B, times the height. So that's generally what we do when we find the trapezoid, a trapezium or a trapezoidal base shape. When we're doing these irregular shapes, essentially what we're doing is we're taking our shape and cutting it into these strips. Cutting it into lots of little strips. And eventually you're going to end up, if you joined all those strips like side by side, you'll end up with like a really, really, really long trapezium with some descript. And that's where this shape comes from, because all of those strips are all going to have the same width. And if you like add them all together, it's going to be like a total length. So that's the reason why we kind of use, this is where the information comes from, or this idea of making a trapezium is what helps us use this formula. So the formula is an approximation. It's not an exact, and we'll have a look at more so how it becomes more exact. So the formula here is A equals W, where A is the area, W is the width of the strip. So when I say width of the strip, you can see here there is a W, and the end length, or E, is the total end length, so the length here and the length here, and all the middle lengths are these ones. So I'm just going to mark them with green. So these are all your middle lengths, so you would add them all together, however many you have, and you would then multiply them by 2, because again we're talking about them being like side by side. So if I cut this strip, this length is going to also apply to this one here. If it sounds confusing, don't worry about it too much. Just note that it's always multiplied by 2, and then we're dividing that by 2, and that comes from the whole concept of a trapezium, which is A plus B divided by 2 times the height of the trapezium. So that is, this formula is a modification and a repurposing of this. Okay, so here is our example. This garden bed was cut into 5-meter wide strips, and the lengths are given in the table. Estimate the area of the garden to nearest 2 decimal places. So here we already know that our W in this case is going to be 5 meters. So each one of these strips is 5 meters wide. Equals 5. So first thing I'm going to do is calculate the total end lengths. So strip 1 and strip 8 are my end lengths here, and I can see them here. So calculate the total end length. So E equals S1 plus S8 equals 0.2 plus 2.1. E equals 2.3. 2.3 meters. So now I have my E. The next thing I'm going to do is calculate my middle length. So I'm just going to leave that there so I can still see my lengths. So M equals all of these here. So we're going to go from S2 to S7. So I need to note that I have 1, 2, 3, 4, 5, 6 numbers. I'm just going to check that later on, make sure I haven't missed anything in my next step. 10.1. Oh. If you're going to do your FSA, S2 plus S3. S7. And those add up to 56.2 meters. Then I'm going to use my trapezoidal rule. So area equals the width times the ends plus 2 of the middles divided by 2. Substitute my values that I know in here. So that W up there was W equals 5 meters. So 5 multiplied by 2.3 plus 2 bracket 56.2 divided by 2, and the answer is going to be a wonderful 286 meters point 75 meters squared, because it's area. So there we are, making sure that you multiply that by 2, and our concluding statement And if you were concerned about it not being accurate enough or wanting to estimate more accurately, what this alludes to is that the more narrow your width, like your strips, so if we split these in half again and made 10 strips, we would start to get more of an accurate area measurement. This is if you are planning to ever go into calculus or follow that pathway, not so much in general that we do this, but the more strips that you add, the more accurate your area is. And so that way you can get a more reliable response. In class, we're going to have a look at an alternative method of estimating the area and then compare it to our trapezoidal rule and see how the two methods fare. So what I'd like you to do now is pause the video and have a go of these two exercises. So you've got those two exercises. So you can pause the video and make sure that you read the question carefully and use your strip values appropriately. All the best. Thanks, guys.